This video lecture is meant to cover the information found in Unit 12, Section 1 on half reactions. One of the things that you'll be asked to do is to determine the oxidation numbers of elements that are in compounds. Of course, if you're being asked to find the oxidation number of just an element that's all by itself, its oxidation number will be 0. But determining the oxidation number of elements in compounds, to do this, you will need to use the periodic table and probably the polyatomic ion chart, table E. So we're going to write here to use the periodic table and table E. Once you figure out what the oxidation numbers are for all the elements in a compound, you will then have to determine you'll have to determine who gets oxidized. To determine who gets oxidized, you're looking for the element whose charge increases. Of course, this represents a loss of electrons, and whoever it is that gets oxidized is also known as the reducing agent. Okay, of course, then you'll need to figure out who gets reduced. And this means that there will be a decrease in the charge. It means that there is a gain of electrons. And it is also known as, whoever is reduced is also known as the oxidizing agent. Okay, push this up. All right, you will also need to use table J to determine if a reaction will happen. So what you are looking for is, of course, on table J, the higher metal will be oxidized and the lower metal will be reduced. Okay, and so of course, for it to be oxidized, the charge is going to go up, and for the element that's going to be reduced, the charge is going to go down. All right, let's take a look at some of the practice problems on the review sheet. First question, you're given this reaction, and it says, in this reaction, K plus ions are. Well, to really figure this out, you have to put oxidation numbers on everything. So all the elements that are by themselves are just zeros. Now, KCl in the compound on the reactant side from the periodic table, potassium can only be a +1, and the chloride can only be a -1. So what we are looking for is what's happening to the K plus ions. So what's happening to these? Well, they are turning into K0. So we have K plus 1 turning into K zeros. So that is reduction. So what we are going to do is +1E. So let's take a look. We see that the potassium is being reduced, not oxidized, so we can eliminate choices C and D. And then when you're left with these two choices, hopefully you now realize that reduction, reduced by losing electrons, does not make sense, because that by definition is oxidation. So choice B is our best answer here. For number 2, given this balanced equation, when 2 moles of aluminum completely reacts, what is the total number of moles of electrons transferred from aluminum solid to H plus aqueous? Well, if we assign oxidation numbers to everything across the way, we have a 0 here. The hydrogen already has a +1, the aluminum already has a +3, and then the H2 has a 0. So if we were to write this as 2 half reactions, what we have is we have 2 ALs at zeros turning into 2 AL +3s. 0 up to a +3 is oxidation. That's a loss of electrons. We always show those electrons on the right side. Now, what do we have here? Each aluminum is losing 3 electrons. From a 0 up to a +3, that's 3 electrons. But since there are 2 aluminum atoms to begin with, each aluminum is losing 3 electrons. So therefore, there are 6 electrons total being lost. If we then do the half reaction for the reduction, we are going to start with the 6 H pluses. And it's going to be reduction, so your electrons are going to go here. We're going to end up with 3 H2 zeros. This is a total of 6 electrons, so the 6 electrons lost here are the 6 electrons gained. Each hydrogen ion is going to gain 1 electron, so there's 6 electrons total for the 6 hydrogen ions total, and you still have 6 atoms over here at the end, each with a 0 charge. So it looks like for every 2 moles of aluminum that completely reacts, the total number of moles of electrons is 6. All right, we're going to keep going on here. We are going to take it now to the notes on electrochemistry. All right, so we are now looking at Unit 12.2, Electrochemistry. For this, you will need to use Table J to figure out who gets oxidized and who gets reduced, and AE Table D. You will need to determine cell voltage from the half reactions. And you will need to determine which combination of chemicals will occur spontaneously. All right, so what we need to see here is, well, first of all, you need to remember a positive voltage is spontaneous, and it will produce electricity. So this is probably a little confusing because when you did free energy problems, it was negative. But for electrochemistry, we are looking at positive voltage being spontaneous. So, all right, let's take a look now at those problems. 12.3, we have 2 problems right here. Given this following reaction, what is the cell voltage for the overall reaction? All right, so what do we have here? We have, this is Mg0, the ions show their charge, and that's Zn0. Okay, so let's take a look at the oxidation half. All right, the oxidation half is Mg0 turning into Mg plus 2 electrons. The reduction half is Zn plus 2 electrons turning into Zn0. Okay, so this is the reduction, this is the oxidation. So when you go to Table D, this is AE Table D, right? What do you need to remember? On Table D, these are reductions. These are all called reduction potentials. So if you are reading, you'll start by looking for the reduction half reaction, and you'll read the voltage as it is. And so when you go to AE Table D, you should find that the voltage for this zinc half reaction is negative 0.76 volts. Now remember, when you are looking for this oxidation reaction, you're actually going to look for it in the reverse. So you're looking for the reaction that is Mg plus 2 electrons turning into Mg0. So when you find that on Table D, you'll see that it says negative 2.37, but because we're reading this as an oxidation reaction, we have to flip that sign to 2.37. So now we just add those 2 numbers together, and we see that the overall voltage is 1.61 volts. So that gives us choice A as the correct answer. Number 4, according to reference table J, which reaction will take place spontaneously? All right, so what are we going to take a look at here? In choice A, we have nickel 2 turning into nickel 0. Okay, so right here in this one, we see nickel being reduced, and we see lead going from 0 up to plus 2. So Pb in this example is being oxidized. So when you go to Table J, in order for this reaction to take place, lead should be higher than nickel. The one that's oxidized is supposed to be higher than the one that is supposed to be reduced. And if you go to Table J, you will see that this is not the case. Lead is not higher than nickel. Nickel is higher than lead. So this is no reaction. All right, and that's because Pb is not higher than nickel. So it is not choice A. Choice B, we see gold going from +3 to gold going to 0. So what we see here is that Au +3 is being reduced. And we see that aluminum 0 is going to aluminum +3. So here we see aluminum being oxidized. So if this reaction is going to be spontaneous, you would expect to find aluminum higher than gold on table J. And you will find that it is indeed, so this right here is our likely choice because aluminum is higher than gold on table J. Put a line here to separate that. Okay, so far that appears to be correct, but let's look at the other choices just to verify. Choice C, strontium +2 to strontium 0. So what we see here is strontium +2 is being reduced. And then we see that the tin 0 going to tin +2 is oxidized. If this was a correct answer, we would expect to see tin higher than strontium, and that is not the case. So for this one, tin is not higher than strontium. So C is not the correct choice. And we're going to find the same thing true here. Fe +2 to Fe0, that is showing as iron +2 is being reduced. And the copper 0 going to copper +2 shows the copper being oxidized. And if this were the case, you would expect to see copper higher than iron, and that is not the case. Copper is not higher than iron on table J. So D is not the correct choice. All right, that's it for Unit 12. Stay tuned for the Unit 13 lesson in a different video.